So this is my prep video for section 3.6 implicit differentiation. So first of all, let's look at what is meant by implicit. Now so far we have actually done equations or functions like x squared, and we know that the derivative is 2x. Now if you look at this, you can see that the function is the y is written explicitly as y equals x squared. It's clear, y equals, there's nothing, I mean y, it is already solved for y, in other words. Okay, but on the other hand, if you look at something like this, now here y is not explicit, it's kind of included in the equation in two different places, say like y is here and y is here. So really, if you want to find y, you need to solve for y, which is kind of difficult and sometimes nearly impossible to solve for y. And besides, sometimes when you solve for y, like for example, if you take this one, right, you might actually get a square root, which might actually not give the whole function because the square root is only positive. But regardless of that, right, what we are trying to do is to look at a situation where y is hidden in an equation, not hidden, it's kind of part of an equation, and not explicitly given as y equals something. Now if that's a situation, how do we actually find the derivative? In other words, how do we find the derivative when y is hidden or included as part of an equation implicitly, not explicitly? So this is explicit and this is implicit. Okay, alright, so we have some simple rules, and if you follow those rules, you'll be okay. So what we do is we differentiate both sides of the equation. First of all, so we differentiate this side and then we differentiate the right hand side. And there are some simple rules to follow. The first rule is that if you encounter a pure x term, that means like something like this. Okay, now here we have x squared, there's no y in it, it's a pure x term. You just differentiate that normally. Okay, so that means the derivative of x squared will be just 2x, that's it. But when you encounter a y term, right, whenever you encounter a y term, you should remember to multiply by dy over dx after differentiating the usual way. So there are two y terms here, but just for convenience, let's take this one. Now this is a y term by itself, correct? Okay, so what you do is you just differentiate it the normal way, so the y squared will become 2y. But you remember to multiply the derivative by dy over dx. So really what we are trying to do is we are trying to use something like the chain rule. Okay, so the rule is when you differentiate an x squared thing by itself, right, then you just differentiate. You differentiate a y squared like here, then you multiply by dy over dx. What about this term? This term is an xy product, so you got to think of them as both different variables, so you got to use the product rule. And when you're using the product rule, when it comes to differentiating the second part, which is a y, remember you need to multiply by dy over dx. And then the final step is, once you do that, you need to solve for dy over dx, because you have an equation and on one side you will have dy over dx. But let's see what we mean through an example. So let's look at this equation. So once again, this is not an explicit equation for y, right, because it's not like y equals something like that, but instead y is included as part of an equation implicitly. Okay, so now we have an equation with both x and y, so we differentiate both sides. So when we differentiate the left hand side, let's see what happens. So we have, first of all, we have a sum. So because we have a sum, we go and use the sum rule. Okay, so we differentiate this and we differentiate this separately and add them together. So when we differentiate x squared, remember the rule, divide any pure x terms as you not divide. We should be actually differentiate. I'm sorry for the typo. Differentiate. Okay. So this is, if you look at the first term, this is a pure x term, right? Okay. So x squared is a pure x term. So when you differentiate that one, you get what? 2x. Can I say that right? So x squared, there's no y in it, you just differentiate 2x, just like the usual way. Then you have the plus, so you have the plus here, and then you have to differentiate y squared. Now remember the rule, when you encounter a y term, remember to multiply by dy over dx after differentiating the usual way. So now we have encountered a y term, y squared. So first we differentiated the normal way. What do we get? 2y. So you get 2y. But you multiply but you remember to multiply that by dy over dx. Why do you do that? Because it's a y term we are using chain rule. Well, why? And then somebody might ask, why can't we do it here? Well, you are really doing it, but then what happens is if you take dx over dx, that is just 1. So really here also we have kind of an invisible 1, okay, but don't worry about it. So just remember the rule. If you have an x thing, you just differentiate it, but if you have a y thing, you differentiate it, but you multiply by 0. Now so this part is the left hand side. What about the right hand side? Right hand side we have 1 and the derivative of 1 will be 0. So now we have this equation. Now we look at the third step. After differentiating, solve the equation for dy over dx. Now you can see that this is just like a normal equation, except that now what we need to do now is to solve this equation for dy over dx. So what we do is we isolate it, and to isolate it we take the 2x over to the other side, right? And then that becomes negative 2x. So we have 2y dy over dx is equal to negative 2x, and then we solve for dy over dx, we get negative 2x over 2y. So we get negative 2x over 2y. If you cancel out the 2, you get what? Negative x over y. Okay, very good. And so that's a good example of doing that. And now if I want to give another example, right? Okay, so let's do something slightly little bit more complicated. So say if I say find dy over dx, right? If x squared plus xy plus y squared equals 1. Okay, so let's take that for a change, right? Okay, so now if you want to differentiate, once again, is it explicit or implicit? Well, it is implicit because y is part of an equation. It's not given as y equals something. Alright, so what do? We differentiate both sides. So when you differentiate this side, first of all you have x squared, which is a term which has only x in it. So what's the derivative of that? So that will be what? 2x. Alright, and now we come to this term. Now this is very important, and it is very important that you realize that now x and y are both variables. So it is like two functions in a product. So you got to use the product rule here, right? So how to use the product rule? Well, let's take right one, which is what? X, right? And then because it's right one, we don't do anything. Now you need to differentiate 2. Now remember, when you take the derivative of y, well, first of all you just differentiate it, and the derivative of y is 1, but because it's a y term, you got to multiply by dy over dx. So it will be what? It will be 1 times what? Dy over dx. Well, you don't have to really write the 1, but okay, 1 times dy over dx, right? Okay. Alright, and now that is right 1 diff 2. So this part is diff 2, okay, right? And now right 2, what is right 2? Right 2 will be y. Now we are not doing anything, why? Because it is just writing y. Right 2 means just writing y. We are not differentiating, okay? So just writing y, right? So we just wrote y, okay? Now we need to differentiate 1. So right 2 differentiate 1. You need to differentiate x now, but x is just a standalone x, and x only thing. So what's the derivative of x? The derivative of x is actually equal to what? 1. And do we need to multiply by dy over dx? No, because we are really differentiating x now, and x is an x thing. There's no y in it, okay? So so this is it, okay, as far as the product rule. Once again, we are using product rule for this part. So x times, okay, the derivative of y. What is the derivative of y? The derivative of y is just 1 times, because it's a y thing, we multiply by dy over dx, plus right 2, which is y. We are just writing y, so we are not differentiating, we just write it. And then diff x, so the derivative of x is just 1. And you don't multiply by dy because it's an x thing, right? Now we go to y squared. Okay, so if you have y squared, well, that's easy. you just differentiate it the normal way, but you got to remember, because it's a y thing, you got to multiply by dy over dx. So it's 2y dy over dx, right? Dy over dx, right? Okay. And then on the right hand side, what do we get? We have 1 here. So we differentiate 1, you get what? You get 0. Okay. So now we have our equation. Now we need to solve this for dy over dx. So first of all, I mean, multiplying by 1 is just the same, so we can just get rid of that. So how do you actually, so we should keep the dy over dx terms here and throw everything else to the other side. So the negative 2x, so what do we have? We have x dy over dx and a 2y dy over dx, right? So if you factor out the dy over dx, what do we get here? So we have dy over dx. If you factor that out, from this one, if you factor out dy over dx, we get what? We get an x. Can you see that, right? So we will get an x, right? Plus from this term, if you factor out dy over dx, what do you get? You get a 2y. Can you see that? 2y. Okay, so we get a 2y, and plus then we have what? We have the 2x plus y. So the 2x plus, so all I did was actually I collected the dy over dx terms together by factoring out the dy over dx from both these terms, right? And then I have 2x from here. Okay, so that's 2x, and then I have what? Y from here, a y from here, and then that is equal to, on the right hand side, we have 0. Okay, so now I can actually solve for dy over dx. What I would do is I would take this over to the other side, right? So let me write the next step. So I will repeat this step, right? So I will write that step. Okay. What happened? Okay, that's equal to, when I take the 2x and y over to the other side, I get what? Negative 2x minus y. Okay, because 2x and y go to the other side, and now all I need to do is to solve for dy over dx. So I just divide by the coefficient x plus 2y. So I would get, it would be dy over dx is equal to, I would have so I would have this on top. So I would have this on top, and then I will have this at the bottom. Alright, so now if they want you to find, so that's the answer, right? We have the derivative. So if you want, for example, find the slope of the tangent to the above curve at, say, if I put say 0 and 1, okay, then how do you do this? So now I want to, so you know that the slope of the tangent is the derivative. So all I need to do now is to go up here and then plug in x equals 0 and y equals 1. So what I would do is I will go back here and I would just plug in what, so I would put x equals 0 because this is 0, and y I would put as what, 1. Okay, so what I would get would be, so what, so negative 2 times 0 minus 1 on top, and then at the bottom I would get what, 0 plus 2 times 1. So this will turn out to be what, this is just 0, right, and then this is just 2, so it's be negative 1 half, right? Okay, so the slope of the curve, or the slope of the tangent at the point 0, 1 would be this. Alright, we'll do more problems in class, so that's it for now. Alright, okay, see you in class.